Welcome, sir. Lokendra, sir. Sir, your voice is not audible.
Yeah, now audible. Everyone,
You're
please.
audible. Yes, sir. You're audible, sir. Please put presentation on slide mode, sir. Perfect, sir.
Yeah. So, good evening to all of you. Today, I will deliver my talk on parallel programming with MPI. So, here is the outlines. We will check the background of message passing interface. What are the current trends of MPI? Then, origins of MPI. Then, we will check basic program of MPI. Hello world and the fundamental concepts. Then we can see the programs mostly in C, C++ or Java. So here we can see the example of Fortran and C. Then there are number of operations are available that is called blocking or non-blocking communications. So further we will discuss the blocking and non-blocking operations on MPIs. So there are some advanced topics. Collective operations, MPI data types, just like as a C, then application topologies, then profiling interfaces. So first of all, I will start a simple program of MPI. Then further we will discuss the environment of MPI programs. How can you write the MPI programs? Then how can you run the MPI programs? So MPI is a API, application programming interface. If you are writing a code in C, so you have to insert some special code into your C programs. So there is some tactics where you can put some lines in the C programs. So here you can see the simple programs of MPI. First of all, you have to include the header files, include mpi.h. The second line is everyone knows about it, standard input output.h. Then third line is for creating the environment of MPI. Then we are talking about rank and size. Here we are initializing in the form of integer rank and size. Then line 5 shows the initialization of MPI environments. Line 6, MPI underscore com underscore rank. It shows the number of process in an environment. Next is the size of the MPI. So it depends on your computer systems. If your computers have i9, i7 or i5, Depending on your current configurations, the size of the MPI depends on your system configurations. Then you can print hello from process. Actually, suppose you are using Core i3. It means you have 4 processes starting from 0 to n minus 1. So Core i3 means you have process 0, 1, 2, 3. Then MPI finalize. So it will close the environment of MPI programs. So these are the simple programs. So I already told MPI stands for message passing interface, which is a way to exchange message between multiple computers that are running in parallel programs. What happened? Day by day, technology increases. Everyone needs to improve their performance or efficiency. We know Amdahl's law. Amdahl's law depicts two things. First one is the how can you improve the speed up. Sequential code cannot achieve the maximum speed up or throughput or efficiency. Because most of the programs we are using loops. Loops consume more and more power, energy, and time. So we need to improve these codes by inserting MPI basics building blocks. So MPI is a model of parallel computing where each process has its own memory. Actually, it works on distributed memory. So distributed memory have their own local memory and data should be shared by passing message between processes. So right now, all the computer systems are latest one, but how can you use the efficiency of these systems? The most simple example of the parallel computing is I am delivering the lectures, someone is hearing the same time, galaxy moving. These are the example of parallel computing. Means simultaneously all these things happening the same time. So the basic concept of parallel computing is multiple computers or processors. We can say the processors are nodes or cores. Each node works on a portion of the computing problem. So if you are using Core i7 or Core i9, so you have to use all the cores, all the CPUs equally to enhance the performance of the systems. What happens if you are trying to compute a matrix of 10 by 10 size? So your dual core computer cannot solve it. But Core i9 or i9 systems can solve 10 by 10 matrix multiplications easily because of the size or because of the efficiency of Core i9 system. So main thing is how can you exchange the data? MPI defines a standard set of functions for exchanging data between nodes. Nodes means there are number of processing elements in a system. Data is explicitly sent by one process and received by another. So it is totally random process. Suppose we are using Core i3, so they have 4 processors from 0, 1 to a 3. So when we are running the programs, so it is getting randomly processed. So if we are decomposing a problem into multiple parts, which process solves which problem size, it is not defined by the users. Systems or compilers or interpreters, it takes randomly and solve the problems. After solving the problems, synchronization is the main things. So MPI combines communication and synchronizations. After decomposition the problems into multiple parts, synchronization is the main property of the MPI programs. So MPI program is made up of autonomous processes that execute their own code. Each process has a unique MPI rank. Rank means your process 0, process 1, process 2, like that. It own memory space and execute independently. So I have already declared that every process have their own local memory to compute the problem and execute the programs independently. So if we are computing independently programs, so it will take less amount of time to compute the problem. So MPI parallel code requires changes from serial code to parallel code. So in the programs, you can see line 1, we add here routines of MPI programs. Then that will create the environment. Then actually there are basic 6 routines of MPI programs. We will discuss further. If we know the 6 basic routines of the programs, we can easily parallelize any programs like C programs or C++ programs or Fortran programs. Main thing is that no programs can be parallelized fully, means 100%. No one programs can be parallelized 100%. So we are applying MPI routines where the programs taking much more time to compute. So we know the loops always takes more times to compute the problems. So we will use MPI routines where their programs taking more and more times. So these are the basic passing models. A process is traditionally a program counter and address space. So every process in a computing systems have their program counter and their local memory space to compute the problems independently. Next one is processes may have multiple threads, programs, counters, and associated stacks, sharing a single address space. MPI is for communication among processes. So there are number of processes in a systems. So MPI routine communicate all these processes together, which have separate address space. So inter-process communication is the main concept of the MPI. Then after decomposing the problems into multiple parts, synchronization is the main thing. How can you synchronize all the programs in a single way? Movement of data from one process's address space to another is the main things, because we are decomposing the large problems into multiple parts, solving them, then combining these results into single one is the main things. So I already told MPI is a Application Programming Interface, API, that defines the model of parallel computing, where each parallel process has its own local memory and data must be explicitly shared by message passing between processes. So we already studied 4 types of parallel computing models: SIMD, MIMD. So here we are discussing only the parallel models. So data parallel, the same instructions are carried out simultaneously on multiple data items. Task parallel, so you can decompose task into multiple parts, different instructions on different data. It means we will further discuss the point-to-point communications or collective communications. So that is the part of these things. Next one is the SPMD, single program, multiple data. So you have a single program, but you have to distribute your data among number of processes, not synchronized at individual operation level. So main thing is the synchronizations, but you cannot synchronize it in individual operation level. So you have to synchronize in the global operation level. Next is the SPMD, is equivalent to MIMD, since each MIMD program can be made SPMD, similarly for SIMD, but not in practical sense. So message passing is for MIMD, SPMD parallelism. So here we are using message passing interface for MIMD, means multiple instructions for multiple data. It means you have to decompose your task parallel, different instructions on different data. Next thing is the cooperative operations for communications. So cooperative means does not interfere with point-to-point communication. Before that, we are discussing the point-to-point communications. In the point-to-point communication involves transferring a message from one process to another in the same communicator. So communicator is the creating an environment. So in a communicator, there are some processes. Suppose there are 4 processes or 6 processes. So point to point means you have to communicate within the communicator. MPI offers both blocking and non-blocking. Blocking means synchronous operations, and non-blocking means asynchronous operations. So we will discuss it further. What are the blocking or non-blocking operations? So these are the point-to-point communication. So in the collective operations, it does not interfere with point-to-point communications. All ranks within a communicator must call the routine. So the message passing approach makes the exchange of data cooperative. So we can exchange the data together. Data is explicitly set by one process and received by another one. So we can see the example. Suppose there are 2 processes, process 0 and process 1. So process 0 send the data and received by process 1. An advantage is that any change in the receiving process memory is made with the receiver's explicit participations. So communication and synchronization are combined in the cooperative operation. That is the main advantage. How can you combine the communication and synchronizations. So cooperative is the very good achievement of MPI. So that is the one-sided operations for communication. So as we know, MPI is a standard interface. So MPI is a standard interface and model for message passing. It is not a compiler interface. So what it should be? It is not a compiler. It is not an interpreter. It is a API. So you can use in any programs like C, C++, Java, Fortran, and Python also. So it is API. So we can use dedicated software, libraries, or much more interfaces for better result or better decomposition of a programs. But it does provide the functions of an interface. So there are number of functions. So basically they are using only 6 basic routines. We will discuss it in the next PPT. So one-sided operations between process include remote memory, reads and writes. So you can see in the figure process 0 and process 1 put the data. So you can so it will going to the memory of process 1. Then only one process need to explicitly participates. So an advantage is that communication and synchronization are decoupled. So one-sided operations are part of MPI2. So they are MPI1, MPI2, MPI-CH also is there. So how can you write the programs? Then how can you run the programs? It is too much easy to run your program. You can run your programs in Windows or Linux in any environment. There is no issue. So you have to use some routines to run before executing their programs. So once again, we are discussing the basic definitions of MPI. A message passing library specification, extended message passing model, not a language or compiler specification. We are already discussed. It is not a language or not a compiler, not a specific implementation or a product. It is nothing like that. So it is simple a API, application programming interface, for parallel computers, clusters, and heterogeneous networks. So where we can use the MPI routines or programs in the parallel computers or clusters. Clusters means the more than 2 computers we are using as a cluster in a cluster forms, or heterogeneous networks means there are different systems. Some using 90 OS, some using Linux, like that. Full featured, designated to provide access to advanced parallel hardware for end users, library writers, or tool developers. Right now, MPI is fully developed, so we can use at the end of end users or library writers for parallelizing the code. So how can you improve the programming codes in the form of efficiency and speed up? So there are some sources, so we can go through the links and studies the MPI programs. So why use MPI? So I already told you key sequential code taking much more time to execute. Why? Because most of the large programs using loops. So loops takes much more times to execute their programs. So with the help of the MPI routines, we can decompose these codes, not whole programs. some of the code we can parallelize. So Amdahl's law says if you are parallelizing 60% of the code, so their speed up is 6 times more. So we will see in the next slide. MPI provides a powerful, efficient, and portable way to express parallel programs. MPI was explicitly designed to enable libraries. So you can use much more libraries to extend your code. How can you improve their efficiency or speed up of C programs or Java programs or Fortran programs, which may eliminate the need for many users to learn much of MPI. So there's no need to learn much about the MPI. First of all, you have to learn about 6 basic routines of the MPI. Then, as per the requirements, you can read more and more libraries of MPIs and you can use it. So that is the minimal MPI programs. So here we use the MPI.h header files as usual. stdio.h, then integer main, integer argc, character argv, then it creates the environments of MPI init. It initialize the MPI environments. Then printf hello world, then finalize. So these are the simple programs, very simple programs. So it uses only 2 routines. First one is the initialization, or next one is the finalize, means you have to close the environment. So main thing is how can you run their programs. Main is the how many process. Okay, we will see the more complex programs in next slide. So the same programs, it is written in the Fortran. So there are a number of experts. Some are doing programs in C, C++, Java, Python, Fortran, Lisp. So most of the programs we can parallelize their code with the help of the MPI. So main thing is how can you parallelize your sequential code into parallel one. So normally we are using 2 types of APIs. First one is the MPI. Second one is the OpenMP. MPI program works on distributed systems. And OpenMP environment works on shared memory. So both are the 2 different concepts. So C and Fortran bindings correspond closely. There's no difference because both the programming C and Fortran are the sequential programs. So main thing is what you have to add in your sequential code. So here you can see we have include MPI.h, then initialize the MPI, then finalize the MPI. Remaining things are the same which is written in the C programs. Same here. You have to use MPI, then call MPI INIT means initialization of MPI, then finalize means you have to close the environment. Remaining code is same in Photon. So how can you handle the error? By default, an error causes all process to abort. So the user can cause routines the return with an error code. So how can you handle the error handling? It is just like as a exception handling in Java. So user can also write and install custom error handlers. So there are some routines. How can you run their code with the custom errors handlers? So there are a number of libraries you can add into your programs for handling the errors. So how can you running MPI programs? So there are number of standards available day by day, MPI 1, MPI 2, MPI CH. So MPI 1 standard does not specify how to run an MPI program, just as the Photon standard does not specify how to run a Photon program. So the initially MPI 1 standard, nothing specify. So in general, starting an MPI program is dependent on the implementation of MPI you are using and might require various scripts, program arguments, or environment variables. So there's a code MPI EXEC. Then you have to write the arguments. How can you execute your MPI programs? Is part of MPI 2 as a recommendation, but not a requirement. So you can execute their programs with the help of MPI EXEC. So finding out about the environment. So here we will discuss the basic building blocks. So we are already told you there are basic 6 basic environments. So we can use a number of compilers to run their programs. So parallel programs enables users to fully utilize the multi-node structure of supercomputing clusters. It means if you are using supercomputers, so you have to use their efficiency as a full capacity. If you are not using their full strength, so there's no meaning of the supercomputer. So MPI is a standard used to allow several different processors on a cluster to communicate with each other. So in a computing systems or in a supercomputer, there are number of processors. So how can they communicate together, then solve a particular problem? So with the help of the MPI, we can communicate the process together and do a job with a minimal time. So we can use your programs to run to run in various compilers like Intel C++ compiler, GCC compiler, Intel MPI compiler, OpenMP compiler. So there are a number of compilers with the help of the you can run your programs in Linux or Ubuntu or any Windows platform. There's no issues. So if you want to use GCC, so first of all, you have to install or load GCC compiler in your environment. So here we are creating the environments. Two important questions that arises early in a parallel programs. How many processes are participating in these computations? So as I already told you, it totally depends your system configurations. That's you are using Core i3, Core i5, Core i7, Core i9 and onwards. Next one is the which one am I? So suppose there are 4 processes or 6 or 8. So how process numbers or process IDs are going to be defined? MPI provides functions to answer these questions. So if you are using MPI routines, so MPI routines have two things, MPI underscore com underscore size. So it will generate the number of processes. Next one is the rank. MPI underscore com underscore rank report the rank a number between 0 to size n minus 1. So if your size is 5, so it is going to from 0 to 4, less than 1. So these are the basic two routines. First one is the how many processes are there with the help of the MPI com size. Next one is the rank. So suppose there are 4 processors. So how can you numbering it from 0 to size minus 1 means process 0, process 1, process 2, process 3. It is totally random. So these are the simple code, simple programs. Nothing is different. Common thing is there. So first of all, we have add the routines MPI.h. So it is the directive to how to parallelize our code. Then there is C code, that is the also C. Then you have to define rank and size. Same programs is there. So main thing is that MPI INIT, these routines function initializes the MPI environment. It takes in the addresses of the C command line argument argc and argb. So these directives should be enough to get our uh, parallel code. So there are two things, rank and size. So rank is going from 0 to n minus 1 depending on your size. So IM rank and size. So suppose there are 4 process. I think they are not generated the output. So when you will get the output, it is totally random. I am process 0, then I am process 1, I am process 2, then process 3. It is totally random. So which programs decompose from 0 to n minus 1, it is totally independent. So and you suppose you want to execute your programs, so we have to write MPI run minus NP. NP is a flag. So how many process you need? Suppose you are required 4 number of processes. So you have to write MPI run minus NP4. So the same program is written in the Fortran language. So how can you send or receive the MPI routines? We need to fill in the details. Process 0 send the data and process 1 receive the data. It is called the intercommunication between the process. Things that need to specify: how will data be described? How will process be identified? How will the receiver recognize the message? What will it mean for these operations to complete? So suppose process 0, main thing is the synchronizations. So process 0 finish the job, then send the data to process 1. Suppose they are process 2 also. So process 1 finish their work and then send the data to the process 2 and then onwards. So main thing is how can you describe the data, how process identify each other. So it's totally compiler based. There is no human interference required. How to calculate their problems in the way. So yeah, you can see the pictorial, with the help of the pictorials, how data get generated or how data transfer plus synchronizations. So here we are using only 2 process 0 and process 1. The process 0 creates the data and send to process 1. After receiving from process 0 to 1, process 1 synchronized all the data in one place. So it requires cooperation of sender and receiver. So this is a very basic example, because here we are using only 2 process 0 and process 1. So cooperation is the main things. Cooperation not always apparent in code. So there is no need to add it into code. It is totally random and depend on your compiler. So processes can be collected into groups. So it means you have to generate the communicator word. Processes can be collected into groups. So it is talking about communicator word. Each message is sent in a context and must be received in the same context. So what purposes you have to send the message? You have to receive the message in the same context. A group and context together form a communicator. So communicator have the number of processors. A process is identified by its rank. So every process is their unique rank from 0 to size -1. So there is a default communicator whose group contains all initial process called MPI_com_world. That is the default communicator group routines MPI com world. Yeah. So these are the MPI. There are some data types of MPI. The data in a message to send or receive is described by triple address count data type. So address, so here we are using MPI int, integer, count, MPI double precision. So MPI data type is recursively defined as predefined corresponding to a data type from the language. There is example. So a contiguous array of MPI data types. So contiguous, everyone knows about this. So contiguous memory locations. So all the data types should be same. A strided block of data types, an indexed array of blocks of data types, and arbitrary structure of data types. So they are MPI functions to construct custom data type such as array of integer float pairs on a row of a matrix stored column wise. So here we can customize the array in the form of integer and float. So MPI, some tags are, how can you receive the tags? So messages are sent with an accompanying user defined integer tag to assist the receiving process in identifying the message. Message can be screened at the receiving end by specifying specific tag or not screened by specific MPI any tag as the tag in the receive. Some non-MPI message passing systems have called tags message types. So MPI calls them tags to avoid confusion with data types. So main thing is of MPI tags is how can you identify the data types without confusion. So we are using tags to eliminate the confusion among the data types. So there are two basic things, blocking and non-blocking send. So there are some syntax. We can see the, just remember the syntax. MPI send start and count, data type, destination, tag, and com. So the message buffer is described by start, count, data type. The target process is specified by destination, which is the rank of the target process in the communicator specified by com. So when this function returns, the data has been delivered to the system and the buffer can be reused. The message may not have been received by the target process. So these are the basic blocking send routines. MPI send, start, count, data type, destination tag, and com. So you have to put these 6 basic routines into MPI send. That is the syntax for MPI basic blocking receive. So we are, when one can receive the MPI message, so you have to add in your routines start, count, data type, source, tag, common, status. So all things are common. So here Source is the rank in the communicator specified by COM. Source means from which source the message is coming. Status contains further information. So what you have to do the perform. Receiving fewer than count occurrences of data type is okay, but receiving more is an error. So if you are receiving some errors, you can check it from the function count. So retrieving further informations. So these are the basic. Status is a data structure located in the user's programs. So there is the in the C program and in the Fortran programs. These are some syntax. You have to just remember it when we are using. It is for the Fortran examples. How can you write the Fortran programs? And as usual, you can write the program in C language also. So why data types? Why we are using the data types? Since all data is labeled by type, and MPI implementation can support communication between processes on machines with very different memory representations and length of the elementary data types, heterogeneous communications. So data type is very much important for any programming language. Specifying application-oriented layout of data in memory. So it will reduce the memory to memory copies. So what happened when you are implementing the codes? Synchronization process wait until all number of the groups have reached the synchronization point. So this is called the barrier. We will see it in the next slide. So separation of messages used to be accomplished by use of tags. This requires libraries to be aware of tags used by other libraries. So you have to distinguish between with the help of the tags. This can be defeated by use of wildcard tags. So if there's some confusion in a code, with the help of the tag, you can eliminate the confusions. Context are different from text. So no wildcard allowed. Allocated dynamically by the system when a library sets up a communicator for its own use. User-defined tags is still provided in MPI for user convenience in organization applications. To use MPI split to create new communicators. So if you want to split your communicators into multiple parts, so you can use the routine MPI split. Many parallel programs can be written using just these 6 functions, only 2 of which are non-trivial. So first two you must be used: MPI INIT and MPI finalize. So when you are writing your MPI course, so first of all, you have to create the environment, and then you have to close their environment with the help of the MPI finalize. Third routine is the MPI comp size. It will generate the number of process, how many process you have, and every process have some rank. So you have to send your data through the routines MPI send, and you have to receive the data through the MPI, the RECV. So there are two types of communications: point to point, and next is the collective communications. So in the point to point communications, uh, so collective operations, we have bcast, broadcast, reduce, receive, number of routines are there. Uh, Collective operations are called by all processes in a communicator. So in a communicator, there are number of processes from 0 to size minus 1. So there, all these operations, collective operations, are used for data movement. All these routines are used for data movement. First one is the MPI bcast, that is called broadcast. It sends a message from the process with the rank root. Root means from 0 to all other process in the group. Just as a broadcasting, one process can broadcast to all other remaining processes. MPI bcast broadcast. Next is the MPI reduce. MPI reduce is the one of the parameters of this function is the operation to be performed. So combines data from all process in communicator and returns it into the one process. Means suppose there are 8 process, so it collects the data from 8 and return to the single one process. So in many numerical algorithms, we can use send, receive, bcast, reduce for simplicity and efficiency. So there are much more data movement MPI is available. Scatter, gather. So scatter operations performs a one-to-all communications. Scatter one to all. It split the message into an equal segments with the IS segment sent to the IS process in the group. So these are the programs. We can see the C program for pi. How can you calculate the value of pi? It is so pi actually is a mathematical function. So we have to add the math.h data files. That is the MPI.h because we are using API of MPI. So here in the programs you can see we are using just MPI com word and num process. So MPI com word means how many processes are there. So it is talking about communicator. So maybe 8, maybe 10. Then rank. So it is generates from 0 onwards. Then it broadcast. So broadcast means so there are number of processes are there. So it will broadcast from root from 0 to remaining processing elements. Or then it will check the calculations of pi programs and then generates the outputs. So what we want, so alternative set of 6 functions for simplified MPI. So for the simplicity of the programs, we can use more data movement or collective communications for reductions. We can use more and more routines. So that is for initialization of the environment. This one is for the closing the environments. It will tell the size of the communicators, and every process have some unique rank. That is for broadcasting. So bcast means sends a message from the process with rank root to all other process in the group. Next one is the reduce. So from all the one of the parameters of this function is the operations to performed. So we have to collect the information from the remaining nodes and compute give to the single one node. So there are some deadlock conditions also there. Send a large message from process 0 to process 1. So there is insufficient storage at the destinations. The send must wait for the user to provide the memory space to eliminate the condition of deadlock. So what happens with process 0, process 1? Send 1, receive 1, send 0, receive. This is called unsafe because it depends on the availability of the system buffer. So you have some space. If you have no space, so your program is going to be halt or not going to generate the desired output. So if you have enough space, so there is no issue to run their programs. So there are some solutions for unsafe problems. So main thing is you can use another one is non-blocking operations. Non-blocking operations means that you start from I send, I receive, like that. Or blocking is used simple one, send 1, send receive 0 1 0 1. So MPI send and MPI receive. MPI send to send a message to another process. Receive to receive a message from another process. So these are the simple send. Main thing is how can you write their syntax. So suppose towards a portable MPI environment, there are some queries. Java API or MPI. Yes, we can use. So any program, C, C++, Java. So what happens? What MPI did? MPI minimizes the time to run a simple programs. Suppose your program's taking a 0.333 millisecond to run a program. So what MPI does, it reduces the time. So we can use our routines where the program taking much more time. Normally, your loops always take some more times. API name in Java. So API name in Java. No. Actually, there are 6 basic routines of MPI: INIT, finalize, send, receive, communicator, word. These are the basic routines you have to use in your programs. How we can import MPI in Java? No, there's no need to import your MPI. You have to write MPI.h. We have to use the header files MPI.h. So every programs you have to write header files, then basic 6 routines. You can see in this program. First of all, you have to configure. Configure means you are using Windows or Linux, right? Then you have to prepare your setups, MPI CC minus MPI trace my program.c. So that is the name of the program. Suppose you have to save your programs, your file my program.c. Suppose that you have to save your programs my program.c. Then you want to run in 10 processing, 10 with the help of the 10 processors. So you have to write next command MPI run minus NP. So that is called number of processors. So here we are write 10. What is used in C in Java? We have to import every 10 what we have to use. Yes. Every programs have another header files. Yes. So right now C, C++, Java, Python, all these have the most of the programming languages uses the MPI. So we have to say MPI dot. There's no basic difference. So you can use MPI dot h. But what happened? You have if you are using the Linux or Ubuntu, so where we have to uh, put some commands to run their programs, basic programs. You have to use the same header files. There is no basic difference. Those like Fortran. Fortran is the oldest one programming languages. So there are some basic difference there. There, all the routines are the same. There is no basic difference among them. So when this how can you run the program? So MPI run minus NP 10. So it means you want to run your programs with the help of the 10 processes, then my programs. So after that, your program runs and deliver the message from index 0 to 9. So if you are familiar with any programming languages, you have to learn just basic building blocks or basic routines. It totally depends. How can you use their basic routines in your programs? So it is just for practice. There are number of programs available. You can see their programs and check how they generate the outputs. So there are basically three MPI 1 features, MPI 2 features, and then MPI CH available in the market. So import MPI.star and use the same routines. Similar to MPI CC compiler, you can use Java C compiler. Yes, same routines. Actually, in the starting, I have said what compiler you are using. You can use ICC compiler, GCC compiler, MPI-CH compilers. So little bit difference are there. So there is not a big issue. What happened? What we say now? For the optimum solutions, when you are using your, you are writing your C codes. So you have to use your compiler built on C programmings for the optimum solutions. If you are using C programs, so you have to use your compiler of C code for the optimum solutions. More questions?
Fine, sir. You can go ahead.
Okay. So just you can see or run some basic programs, and you can use basic routines: send, receive, broadcast, reduced. Writing a program that send a message around a ring, that is process 0 reads a line from the terminal and send it to process 1, who sends it to process 2, etc. The last process send it back to process 0, who print it. So the time programs with MPI W time find it. So if you want to check how much time your programs are taking, so you can use the routine MPI underscore W time. So when to use your MPI program? So I already said, when you want to parallelize your code or you want to minimize the running time, so we can use where portability and performance. So where you want to performance means if you want a program uh, uh, speed up and efficiency. If you want a program have some speed up and efficiency, where we can use MPI. If they are different or irregular data structures in the programs, so we can use the MPI programs. Where building tools for others, so you can use most of the libraries to progressive your programs need to manage memory on a per processor basis. So the program setup a communication group of processes where each process gets its rank, print it, and exit. So they have suppose they have 4 process. they will print the message one by one and exit from the program. So main thing is that MPI program starts simultaneously on all machines. For example, if we had 10 machines, suppose that, then running this program, suppose we are running a single one programs. So, suppose we are using 10 machines. So running this program would means that 10 separate instances of this program would start running together on 10 different machines. This is the fundamental difference from ordinary C program, where when sometime said run the program, it was assumed that there was only one instance of the program running. The first line that is called MPI studio we are using most of the time in the program should be familiar to all C programmers. It includes the standard input-output routines like printf. The second line we are using in the programs, MPI.h, include the MPI functions. The MPI file MPI.h contains prototypes for all the MPI routines in the programs. This file is located in the source of the programs, or actually we want to look into it. The program start with the main which takes the usual two arguments, argc and argv. Already we see in the programs. The programs declare one integer variable node. Node means we can see the core or process. The first step of the program, we are writing MPI underscore INIT and argc comma and argv. So it will initialize the MPI environments and generally set up everything. This should be the first command executed in all programs. This routine takes pointers to argc and argv, looks at them, pull out the purely MPI relevant things, and generally fixes them. So you can use command line arguments as normal. So in the next, you can see MPI com rank. Using it, it adjusts to node. Node means how many processes are there. So you have to start from zero onwards. MPI com rank will set node to the rank of the machines on which the program is running. Remember that several instances of this program starts up on several different machines. When things program is run, these processes will each receive a unique number from the communicator rank, MPI com rank. Because the program is running on the multiple machines, each will execute not only all the commands. Thus, for suppose you are you want to print a hello world message, so you have to write hello world from process 0 comma node. So if you are writing the command MPI run minus NP4, so it will print 4 messages. Hello world from process 0, from process 1, from process 2, from process 3, like that. But it is totally randomly. Hello world from node 2, then hello world from node 0, like that. It is totally independent depending on your machines. So the last, when not to use MPI. Regular computation matches HPF. So, but the percentage and HPF comparisons in IKS 97. So, suppose you have a simple programs and you are going to apply the MPI routines. So there is no impact on that programs. So we have to MPI routines where we can minimize the programs. Minimization means we can reduce the time complexity of a programs. So these are the basic MPI routines. And the last, the parallel computing committee has cooperated on the development of a standard for message passing libraries. So MPI is a committee to develop day by day some routines. One can also one can also develop their own routines and share with the committee. There are many implementations on nearly all platforms. So one can implement on any platforms, any programming interfaces, because it is API, so you can use it any programming modes. MPI subsets are easy to learn and use. So if you are practicing more and more, so it is very easy to run the programs. So lots of materials are available and every mode, online and offline modes. So one can just see and check the programs and run the programs and do some changes and see what effects happened when we are changing some lines of codes. Thank you. Any other questions?
Dear participants, if you have any questions, you can post in the chat box.